Hello guys, good evening everyone. So guys, can you able to hear me? Can you able to see me? सुन पा रहे हैं क्या? Hello Kanchiram, hello Sabah, Lata, Sayan, everyone. How are you guys? Good evening everyone. So guys, welcome to Unacademy platform. So welcome to practice session 3000 practice problems. So this is a part 21 guys. In this we'll discuss the probability questions. Welcome everyone. So let me introduce myself. Myself Praneet Kalyanam. I'm maths educator at Unacademy. I have 10 years experience in teaching IIT-JEE maths. Previously I have worked in Narayana China campus, Hyderabad, and before that I have worked in Akash, Bangalore. I have studied in IIT Roorkee. Hello guys. Guys, just confirm me whether you are able to see me or not. Is it live or not? Just confirm me guys so that we can start the class. Can you able to hear me guys? Can you able to see me? Hello Jatin. Namaste. How are you? Right. Perfect. Chalo then, let's start. So guys, this is my profile in Unacademy. You can search my profile in Unacademy. You can easily find me. You can search my name Praneet. And you can follow me. If you start following me, you can get all the notifications about my special classes. When is my special classes? Whenever new batches comes, whenever I start plan a new course, you will get to know. Okay, right. Hello Neha, Jatin, good. Hello. Chalo guys. So guys, we have two IIT-JEE subscription plans. One is Plus subscription and the other one is Iconic subscription. The difference between Plus and Iconic is, in Plus we'll get India's best educators and interactive live classes, and structured courses will get it, unless special classes, structured special courses, and you'll get notes and DPPs in PDF format. You can download it and you can do it, and unlimited live quizzes and unlimited test and doubt clearing sessions will be there. And in Iconic, you'll get personal coach. India's top educators, you'll get personal coach, and there will be study planner and expert guidelines and test analysis. All these extra features you will get it in Iconic. Okay, so you can enroll these two courses guys. If you want to join Plus platform or if you want to join Iconic platform, you can enroll for these two. So you can use the referral code to get 10% discount. I'll tell you the details about this course, how to join and all. You can go to the learning app and you can click Plus and select your goal, which is IIT-JEE, and press on get subscription. You get the packages for Plus and Iconic separately. You can enter this referral code Praneet10. You'll get instant 10% discount. Good evening, Pranav. So these are the advantages of Plus subscription or Iconic subscription guys. You can learn everything from your home. So unlimited access to all the courses. You can join unlimited courses and practice test. So there are batch courses are there, separate batch courses. There are so many batches are there, and you will get mentorship and guidance from top educators, and they'll cover entire syllabus and they'll clear your doubts, and you can check your performance in your live test series. Okay, and you get all the notes and daily practice papers in PDF format. You can download it and you can complete. You can revise it multiple times. Okay. So these are the packages guys. These are the packages for Plus and Iconic. For Plus it is 1 month, 3 months. We have different packages are there. Okay, and these are the Iconic packages. You can compare with this, and you can use this referral code Praneet10 so that you get 10% instant discount. You get it. Okay, right. So guys, in Unacademy, 28th November 8 p.m. we'll have this session guys in IIT-JEE Maths Amarnath Anand sir and Vikas Gupta sir, two top educators from Kota. They are coming together live at 8 p.m. 28th November. So everyone enroll for this class and meet them in 8 p.m. 28th November. Okay, right. Chalo then, let's start, guys. Let's start doing this question. This is 2019 mains question. Let's solve this question. There is a set S which contains 20 elements 1, 2, 3, 4, so on up to 20. So we need to select a subset B from this set S. We can say this as a nice if the sum of the elements of B is equals to 203. If the sum of the elements of set B is equals to 203, we call it as that set as nice. So what is the probability that a randomly chosen subset of S is nice? So let's calculate probability of A. Probability of A is equals to N of A by N of S. N of S is total number of elements in sample space. Now tell me how many ways we can choose a subset out of 20 element subset, 20 element set. A 20 element set has 2 power 20 subsets are there. If N of A contains, that means if a set A contains N elements, the number of such subsets we can possible for that set is 2 power N of A. So here N of S, number of elements in set S is equals to 20 elements. So number of subsets we can have is 2 power 20. How we can get it is, one we can take it or we may not take it. How many ways? 2 ways. Same way. Either we can select 2 or we may not select 2. 2 ways. So like that, 2 into 2 into 2 into 2 into 20 times, which is 2 power 20 times. So 2 power 20 subsets are there. Out of these 2 power 20 subsets, how many subsets are nice? That's what we need to calculate. So if you calculate sum of all the elements, let's see what we get it. If you calculate sum of all the elements, 1 plus 2 plus 3 plus so on up to 20, if you calculate, this is nothing but sum of first 20 natural numbers. For that we have a formula, n into n plus 1 by 2. So in place of n, we just need to substitute 20. 20 into 21 by 2, which is equals to 210, guys. But actually we need to get 203. 203 we should get, it means 7 we should subtract. So 7 we should subtract. That means out of set S, that means the different possibilities I am telling it, guys. One possibility is if you can take a set B is equals to total elements in S minus single element 7 if you subtract it. Yes, sum will get 210. In this case, we get sum is equals to 210. Sum of the elements 210. Sorry, not 210, guys. 203. 1 second. Let me erase this. Yes. If you can subtract 7 from 210, we'll get 203. If you subtract only one element, 7, we get 203. This is one possibility. What is the second possibility, guys? Second possibility we have is subtracting 2 elements. Subtracting 2 elements means the set B is equals to S minus maybe 1 comma 6. You can subtract it, or maybe 2 comma 5 we can subtract it, or maybe you can subtract 3 comma 4 you can subtract it. These are the possibilities we have. Clear? Right. So now 3 element sets we can subtract it, guys. 3 elements we can subtract it. 3 elements if I want to subtract, how many ways I can subtract it? Let's see. B is equals to S minus 1 comma 2 comma 4 we can subtract it. Guys, is it clear? So how many possibilities we are getting, guys? Till now, how many possibilities we got it? 1, 2, 3, 4, 5. So 5 possibilities we got it. Any other possibilities? Guys, any other possibilities? So here we are taking total 19 element subsets we selected here. 19 element subsets. Here 18 element subsets we have taken. Here 17 element subsets we have taken. So total 5 subsets we are getting, guys. So total answer is 5 by 2 power 20. So fourth option is the answer. Correct, na? So guys, is it clear? Everyone understood this? Perfect. Chalo, let's move to the next question. Next question. If two different numbers are taken from this set 0, 1, 2, 3, so on up to 10, so that means total 11 numbers are there. Out of this 11 numbers, we need to select two numbers. The probability that their sum as well as absolute difference also should be multiple of, both multiple of 4. Okay, so let's calculate the probability. Probability of A is equals to n of A by n of S. So tell me, what is n of s, guys? N of s is total number of ways of selecting two numbers out of 11 numbers. Isn't it 11C2, guys? How many ways we can select two numbers out of 11 numbers? 11C2 ways we can select two numbers. And out of this, we need to select two numbers in such a way that sum as well as the difference should be multiple of 4. Let's see what are these different possibilities. Let's count the different possibilities, guys. The different possibilities we are getting is, first possibility 0, 4 you can take it, 0, 4 you can take it, and the second possibility 8, 0 we can take it, or 0, 8, anything is fine. Next possibility is what, guys? 2, 6, can we take it? Can we take 2, 6? That is one possibility. And what is the other possibility? Can we take 2, 10? Fourth possibility is 2, 10 we can take it. Why? Because see, sum is multiple of 4. Difference is also multiple of 4. Sum is difference. Sum and difference both are multiple of 4. Right. Any other possibilities, guys? Let's take another possibility. What is the another possibility we have? 0, 4 we have taken, 0, 8 we have taken, and 2, 6 we have taken. And can we take something like, here difference is 4, guys. Difference is 4 and the sum should be 8. And here sum is, difference is 8 and sum is 12. What are the other possibilities, guys? Tell me, any other possibilities other than this? Any other possibilities? 0, 4, 0, 8 we have taken, and 2, 6 we have taken, 2, 10 we have taken, 6, 10. Yeah, correct. 6, 10. Why? Because 6 plus 10 is equals to 16, multiple of 4. 6 minus 10 is 4. Yes. Any other possibilities? 8, 4 we can take it. Yes, exactly. 8, 4 we can take it. Any other possibilities, guys? Any other possibilities other than this? 0, 4, 8, 0, 2, 6, 2, 10. Difference and sum both should be multiple of 4. Any other possibilities other than this? That's it, right? That's it, right? Total 6 possibilities we are getting, right? So these 6 possibilities are the total number of favored cases, which is 6 by 11C2. So 6 by 11C2 is how much, guys? 11 into 10 by 2, which is equals to 55. So 6 by 55 is the answer. So first option is the answer. Correct? Right, perfect. So first option is the answer. Number of total cases is 11C2, which is 55. But out of this 55 cases, only 6 cases are satisfying the given two conditions. Sum as well as difference should be multiple of 4. Next one. Next question, guys. 3 randomly chosen non-negative integers x, y, z. Non-negative integers means what, guys? Non-negative integers means either positive integers or integer 0. 0 is also a non-negative integer. So we can take either 0 or non-negative integers. 0 or positive integers. We call it as non-negative integers. X, y, z are found to satisfy this equation. Then the probability that z is an even number. Yes, Krishna. I have a batch. I'm taking a batch for droppers. It started 2 months back. So in that we'll discuss both 11th and 12th. We'll cover all the syllabus of 11th as well as 12th. Okay. So that is for basics to advanced level, both for mains and advanced. So tell me guys, so here we can say that x greater than or equals to 0, y greater than or equals to 0, z greater than or equals to 0. So this is a condition he gave. So what is the probability that probability of A is equals to n of s by, sorry, n of A by n of s, n of A by n of s. So tell me, first we need to calculate number of non-negative integral solution. What is the formula to calculate number of non-negative integral solution, guys, for x plus y plus z? Otherwise, we'll take the general formula, guys. Let me discuss the generalized formula so that we'll learn how to calculate the number of solutions. Suppose if you take x1 plus x2 plus so on up to xr is equals to n. If I want to calculate number of non-negative integral solution, for that the formula is n plus r minus 1 cr minus 1. This is the formula to calculate number of non-negative integral solution. So according to this, the given equation is x plus y plus z is equals to 10, guys. So for that, n is equals to how much? 10. What is our number of variables? 3. So if you substitute here 10 plus 3 minus 1, C3 minus 1, which is equals to 12C2. So 12C2 is going to be number of n of s, guys. Sample space, number of elements in sample space is going to be 12C2. Is it clear? 10 plus 3 minus 1, C3 minus 1, 12C2. So we can calculate 12C2 later. Okay. So now we need to calculate n of A. To calculate n of A, n of A means here z should be even. Z should be even means how many cases are there, guys? Z can be 0. This is one case. If z is 0, what is the possibility we are getting it? X plus y is equals to 10 we are getting it. In this number of solutions are how much? 10 plus 2 minus 1, C2 minus 1, which is equals to 11C1 we are getting it. Yes, we are getting 11C1 plus next case. This is the first case, guys. As he is saying z is even, for z is equals to even, the case we are getting is 11C1. Same way, second case. What is the second case, guys? Second case is z is equals to 2. This is the second case. If z is equals to 2, x plus y plus z is equals to 10. So that is x plus y is equals to 8. So in that case, the number of non-negative integral solutions is 8 plus 2 minus 1, C2 minus 1. Two minus 1. And how much we get it? 9C1, right? This is 9C1, guys. Same way, third case we'll discuss. What is the third case, guys? Let's discuss the third case. Third case is when z is equals to 4. Correct or no? What is the answer, guys? This is third question, right? Third question, okay. Stylish boy Raja. Stylish boy Raja. C is correct answer. Whatever you are saying is correct. C is correct, guys. Shivam, C is correct. Let's see how we get C. Right, Z is equals to 4 if I take it. X plus Y is equals to 6. In that case, we're getting 6 plus 2 minus 1. C2 minus 1, which is equals to how much we get it? 7C1 we get it. So here 7C1. And the next case, guys, fourth case we'll discuss now. So what is the fourth case, guys? Let's take fourth case here. Fourth case is Z is equals to 6. If you take Z is equals to 6, X plus Y is how much? 4 we get it. In this case, how much we get it? 5C1 we get it. Correct? Next. Fifth case is Z is equals to 8, guys. If I take Z is equals to 8, X plus Y is equals to 2. In this case, we get 3C1. 3C1 we get it. Next. Sixth case we'll take it. What is the sixth case, guys? Sixth case is Z is equals to 10. In that case, X plus Y is equals to 0. In that case, there is only one solution, 1C1. Correct. We just need to add all this. If you add all this, how much we get it, guys? If you add all these values, so tell me, 1 plus 4, 1 plus 3, 4, 4 plus 5, 9. 9 plus 7, 16. 16 plus 9, 25. 25 plus 11, 36. So 36 by, denominator is how much? 12 into 11 by 2. That's what we're getting it. So here 3. So total is how much we're getting it? 6 by 11 we get it. 6 by 11. Where we getting it? Third option we're getting it. Correct now? Everyone understood this? Any doubts, guys? Anyone has any doubts? Is it clear? So n of s is 12C2. Number of non-negative integral solutions of x plus y plus z is equals to 10. Next, n of a is z has to be even. That means z can be 0, 2, 4, 6, 8, 10. 6 cases. For these 6 cases, we just calculated the solutions. 11C1 plus 9C1 plus 7C1 plus 5C1 plus 3C1 plus 1C1. Clear now? Okay, perfect. Perfect. Very good. Next question, guys. Yeah, this is the next question we have. 12 identical balls are to be placed in 3 different boxes. You can take these 3 different boxes as namely A, B, C. You can take it like this. 3 different boxes are there. Then the probability that one of the boxes contains exactly 3 balls. One of the boxes contains exactly 3 balls, guys. Okay, right. So what I'll do is probability of given event A is equals to probability of A is equals to n of A by n of S. But what is n of S? N of S is, see, when 12 identical balls are there, each ball I'll take it. I can put it in any of the 3 boxes. First ball I'll take it, I can put it in any of the 3 boxes. Second ball I'll take it, I put it in any one of these 3 boxes. So total how many possibilities we get it? 3 into 3 into 3, 3 power 12. 3 power 12 ways we can put this 12 identical balls into 3 different boxes. Now what he is saying, probability that one of the boxes contains exactly 3 balls. One of the boxes contains means out of these 3 boxes, which box contains exactly 3 balls? Whatever box, we can choose it. Correct or not? So out of these 3 boxes, we need to select one box to make it 3 balls in that. So once we select one box, let's assume that I selected box A. Let's say I have selected box A. So if I select box A, in that box, I will put 3 balls. How many ways I can put 3 balls? Only one way only. Why? Because these are identical balls, guys. These 12 balls are identical. So we'll take 3 balls and we'll put it in box A. And remaining how many balls are there? If you put 3 balls in that, remaining 9 balls will be there. Each and every ball can be put it in 2 ways, either here or here. 2 ways are there. So it will be 2 into 2 into 2 into 2 power 9. So this is the answer, guys. 3C1 into 2 power 9 by 3C1 into 2 power 9 by 3 power 12. So guys, clear now? Everyone understood this? Or any doubts, guys? So if you simplify this, we get the answer. If you simplify this, you get the answer. Clear now? So these are identical balls, guys. These are identical balls he gave. So I think this question is mistake, guys. Why? Because he is giving identical here and he is giving answer as first option. So instead of taking identical, if you take different balls, then the answer is going to be probability of A is equals to. Suppose if you take identical, we get this answer. If it is different, in that case, we get it like this. 12C3 will get it into 2 power 9 by 3 power 12. We get this if there is different balls. Clear now? So guys, is it clear? If identical balls, this is the answer. If different balls, this is the answer. So I think question is mistake. Instead of identical balls, he should give different balls. In that case, answer is first option. Correct? Is it clear, guys? Everyone understood this? Right. So if you expand this 12C3 into 2 power 9 by 3 power 12, we get the first option as an answer. Stylish Raja, understood now? You didn't understand n of a? Okay, right. Let me tell you guys. See, what he is saying is one of the boxes contains exactly 3 balls. One of the box contains exactly 3 balls. So what we can say is, instead of taking identical, suppose if you take distinct balls, we need to select any 3 balls to put it in one box. I am selecting 3 balls out of 12 balls. If they are distinct, 3 balls I selected. Once I selected 3 balls, I put it in any one of the boxes. Why? Because he is saying in particular box. One of the box means he is saying it is particular box. So if it is particular box, if we put 3 balls here, 3 balls, remaining 9 balls, we can put it in any of the remaining 2 boxes. How many ways? 2 ways. 2 into 2 into 2 into 9 ways. By 3 power 12. So this is going to be answer for this. If it is distinct, if it is identical, and we don't need to take this 3 also. Why? Because if it is one of the box, probability that one of the box contains, that means one particular box contains exactly 3 balls. In that case, we don't need to select 3 boxes also. We don't need to select one box out of 3 boxes also. Clear or not? Now you understood? So the question is mistake for this question. It is not 12 identical balls. It should be 12 distinct balls. 12 distinct balls. Clear? Right, clear now? So the question is, it has to be 12 distinct balls, not identical balls. Then first option is correct. Otherwise there is no option actually. Clear? So the question should be distinct balls, not identical balls. Correct or not, guys? Right, perfect. Next question. Right. See, for identical, we don't need to select 3 balls, right? See, if there is identical balls, how many ways we can select 3 balls out of 12 identical balls? One way only, right? Shivam, out of 12 identical balls, how many ways we can select 3 identical balls? You tell me. One way only. Correct or not? Let's say 12 identical balls are there. And how many ways we can select 3 identical balls? Is it one way or 12C 3 ways? Tell me. Correct. It is one way only. So if it is distinct balls, in that case 12C3 ways we can select 3 balls. Okay, right. Right, perfect guys. Chalo then. Next question. 3 boys and 2 girls stand in a queue. The probability that number of boys ahead of every girl is at least one more than number of girls ahead of her. Okay, let's see this question, guys. Probability of A is equals to n of A by n of S. N of S will calculate first. So tell me guys, 3 boys are there and 2 girls are there. And 3 boys and 2 girls, how many ways we can arrange it in a queue? Isn't it 5 factorial, guys? Correct? Isn't it 5 factorial? The probability that number of boys, they are standing in a queue, how many ways we can arrange them? 3 boys and 2 girls in a queue, how many ways we can arrange them? 5 places and 5 objects. Isn't it 5 factorial ways? Yes, 5 factorial ways we can arrange them. But what he is asking, according to him, number of boys ahead of every girl. Let's assume that they are standing like this. Okay. So number of boys ahead of every girl is one more than number of girls ahead of her. Okay. So let's take the different cases here. So let's take the first case. First case is 5 cases we're getting. Yes, total 120 ways we get it. Yes, correct. You're right. Denominator is like 120 and the numerator we should calculate now. Okay. Right. Let's calculate the numerator, guys. So numerator, what we can say is number of boys ahead of every girl is at least one more than number of girls ahead of her. So let's see how I'll analyze this. So I can write it like this. See, Z1, Z2, number of boys ahead of every girl is at least one more than number of girls. Okay, one second. So first we'll arrange boys, guys. B1, B2, B3 and Z1, Z2. Correct. So this is one possibility. This is one possibility, guys. Okay. So what we can do is we'll remove this 1, 2, 3. We'll just remove this 1, 2, 3 and just check it. Now tell me, guys. See, this particular girl, before that girl, 3 boys are there. Before one girl, before this particular girl, 3 boys are there. And how many girls are there before her? 0 girls are there. So can I say that number of boys ahead of this girl is more than number of girls ahead of this? Correct or not? This is one case. How many possible ways we can arrange this ways, guys? 3 factorial into 2 factorial. Why? Because first 3 boys in 3 places, 3 factorial ways. Next 2 girls, 2 factorial ways. Correct or not? Right. This is only first case. Next, second case we'll discuss. Let's see what is the second case, guys. In second case, boy, girl, boy. This is a second case. Now just check it. See, in front of this first girl, 2 boys are there. In front of this first girl, 2 boys are there. So 2 is greater than 0. And in front of this particular girl, 2 boys and 1 girl. 2 is greater than 1. So this case is also satisfying. This case is how many? Again 3 factorial into 2 factorial case. Correct. Different font. So different font means what? You want bigger font or a smaller font? You're not able to see these questions, guys. Can you able to see these questions? Font is fine, or should I increase the font? Should I increase the font size? Sans tripod. Okay, right. Yeah, this is a second case. What is the third case? Let's see the third case, guys. Let me see the third case. Third case is, it's fine, right? Okay, right. So the third case is like 1 boy is there, and next 1 girl is there, next, and then boy is there, and then girl is there, and then boy is there. This is another case. This is again 3 factorial into 2 factorial. Correct or not? Now, next, one more case, guys. One more case. Next, fourth case. Fourth case is what? First boy is there. Next girl is there. Next boy is there. Next 1 more boy is there. Next girl is there. This is another case. Again 3 factorial into 2 factorial. Any other case we get it, guys. Let's check it whether we get any other case or not. So yes, one more case we'll get it. What is that case, guys? Tell me. First compulsory, it should be boy. No doubt about it. Next, second girl case already over, right? So many cases we discussed. Boy, girl, 2 cases we discussed. Boy, girl, boy. We discussed. Next, boy. Let's see how many cases we discussed for boy. Boy, already 2 cases are over. Let's check it if we get another case or not. Let's check it. Yeah, boy. Girl, boy we discussed. Boy, girl, we discussed. Have we discussed this girl, boy, guys? Girl, boy, girl. We discussed this case. Girl, boy. We didn't discuss this. Correct or not? Right? Right, this is another case which is 3 factorial into 2 factorial. So total 5 cases I am getting, guys. Is it clear? All the 5 cases are satisfying whatever he is giving the condition. Correct. So total 5 into 12. Total number of cases I am getting here is 5 into 3 factorial into 2 factorial, which is 5 into 12, which is 60. 60 by 120, which is 1 by 2, I am getting it. So other than this, any possible values, other than this, any possible cases? Everyone understood all these 5 cases? Are any doubts, guys? If you have any doubts, tell me, guys. First, second, third, fourth, fifth. Any case, if you have doubt, we'll discuss that case again. If anyone has any doubts in any particular case, we'll discuss that particular case. Why that case is favorable to our required probability, required event. Everyone understood this? Any doubts? If no doubts, we'll move to the next one. Got it right? Clear? Okay, perfect. Perfect. Chalo then, let's move to the next one, guys. Right, next question. 4 fair dice are each having 6 faces numbered 1, 2, 3, 6, 1, 2, 3, 4, so on up to 6. How to think the cases, because, okay, right, let's discuss one case. One case we'll discuss, because one case I'll discuss, remaining cases you tried, okay. So let me check it, how we can decide, how we can analyze these cases. So compulsory first boy should be there. Suppose, let's say first girl is there. Suppose, let's say. First girl is there, what will happen is, either we should get girl or girl boy. Let's assume we are getting girl boy. If I get girl boy, in front of girl, number of boys is 0, number of girls is 0. But he is saying number of boys ahead of every girl should be greater than number of girls ahead of her. So compulsory first one should be boy only. Let's say if second one is girl, let's say. Second one is girl. Let's assume that first one is boy and second one is girl. Let's say boy girl. See here, we have taken boy girl. So if second one is girl, for this girl, in front of this girl, how many boys are there? Only one boy is there. In front of this girl, how many girls are there? Only 0 girls are there. So 1 is greater than 0, right? That's what he is saying. Number of boys ahead of every girl should be more than number of girls ahead of every girl. So suppose if you take this third one, first case you take it, guys. First case if you take it, for this girl, in front there is three boys are there. In front there is no girls, so 3 greater than 0. And for this girl, in front how many boys are there? 3 boys are there. In front how many girls are there? Only 1 girl is there, so 3 greater than 1 or not. So both the conditions are satisfying for both the girls. So we can say that first case is correct. Yes, first case is correct. Next, second case, third case, fourth, fifth. These many cases we're getting it. Clear now? Right. So guys, I am from Hyderabad, guys. Right, chalo, let's move to the next one. So this is the next question we have. 4 fair dice, D1, D2, D3, so on up to D4, each having 6 faces numbered 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 are rolled simultaneously. The probability that D4 shows a number appearing on one of D1, D2, D3. Okay, right, chalo. Let's discuss this question, guys. Probability of A is equals to, so tell me, when 4 dice are rolled, what is the probability, guys? What is the n of s, number of possible outcomes, how many will get it? Isn't it 6 power 4? Isn't it 6 power 4 or not? 6 into 6 into 6 into 6, which is 6 power 4 only. Correct. Next. So what is the possibility he's asking? What is the required condition he's asking? When 4 dice are rolled, let's say here D1 is there, here D2, here D3 and here D4. Okay. So in that case, what he is saying is, whatever D4 showing, D4, whatever it is showing, should be one of D1, D2, D3 only. Okay, so here different possibilities are there. So let me analyze these different possibilities, guys. So the first possibility is D1, D2, D3 is showing different numbers, just like 1, 2, 1, 3, 5. Let's say different numbers it is showing. So how many different numbers it can show, guys? 6 into 5 into 4 only, right? These many different numbers it can show it. Why? Because for D1 6 possibilities are there. For D2 5 possibilities only. Why? Because it should not repeat different numbers. 6 into 5 into 4 only, right? Right. Once different numbers for D1, D2, D3 selected, D4 should be any one of these three. Either it should be 1, either it should be 3, or either it should be 5. Correct? So can I say that 3 possibilities for this? 3 possibilities for the first case. That means first 3 dice are showing different numbers. In that case, we'll get 6 into 5 into 4 into 3. Correct now? Aryan. Clear or not? Right. Next, the second case I'll discuss, guys. What is the second case we have? Let's take the second case as, so D1, D2, D3 and D4. So out of these 3 dice, 2 dice are equal. Let's take 2 dice are showing the same number. Let's take something like this. First die and second die is showing same number, and third die is taking other number. Let's say. Guys, clear? So for that, how many possibilities are there? Let me check it this way. We need to select 2 numbers, 2 different numbers we need to select it. 6 into 5. Okay, 2 numbers I selected. These 2 numbers, I can select, let's assume that I have selected 2 and 3. So these 2 numbers, either I can select 2, 2, 3 I can select, 2, 3, 2 I can select, 3, 2, 2 I can select, or 3, 3, 2 I can select, 3, 2, 3 I can select. Correct or not? 2, 3, 3 also I can select it. So total how many ways I can select it, guys? 6 ways I can select it. Sutaria, you didn't understand? Which case you didn't understand? First case or second case? Which case you didn't understand? Yeah, 91 by 216 is correct, guys. 91 by 216 is correct. Which case you understand, so that we'll discuss that case again. Okay, right. 6 into 5 into 6. How we got 6 into 5? 6 into 5 is because we need to select 2 distinct numbers. 2 distinct numbers we need to select. That's why 6 into 5. And this 6, once you select 2 distinct numbers, let's assume I selected 2 and 3. So 2 and 3, I can arrange it in these 6 ways. Okay. So once I select these many ways, let's say D4, I can take either 2 or 3. So again 2 possibilities are there. So these many possibilities for case 2. Guys, clear? First, distinct numbers in D1, D2, D3. Next, 2 numbers are same and 1 number is different. Third case is, so tell me guys, what is the third case? Third case is all the 3 numbers are same. D1, D2, D3. All the 3 numbers are same, guys. That means all are 2, 2, 2. All are 1, 1, 1. All are, so like that, how many cases we'll get? 6 cases only, right? 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 6, 6, 6. So total 6 cases I am getting it. Okay, right. Out of 6 cases, let's say here 2 to 2 I got it. Here how much we should select it for D4? Compulsory it is one possibility only, right? What is that possibility? 2 only. So here only 1 possibility we are getting it. So that means this is 1 possibility and this is another possibility. This is another possibility. All these possibilities we need to add it here, guys. Correct or not? Only 6 possibilities we are getting it. All are 1s, all are 2s, all are 3s, so on up to all are 6. So tell me, if you substitute here, what we get it? This is 20 into 3. So that is 6 into 60. Next, if you take 6 common here, 6 5s are how much, guys? 6 5s are 30, right? 30 into 2. How much we get it, guys? 30 into 2. Again 60 we are getting, right? Again 60 we are getting it. and here 1 we getting it. Okay, see, somewhere we have done wrong. Let's see where we have done wrong. 20 into 360, correct only. Okay, one second, guys. Somewhere we have done wrong. Let's see where we have done wrong. 6 into 5 into 4. Yeah, that is correct. Into 3. Yeah, that is also correct. 6 into 5 into 4 is 20 into 360. Yes, 6 into 60, correct. Next case. 2 are same, 1 is different. So 2 to 3. Right, here already in 6 into 5 itself we selected 2, guys. Here 2 won't come. One second, this 2 won't come. Why? Because here already 6 into 5 itself is 2, 3, 3, 2. Both are coming. So here we can't change the, again we can't arrange them. Right, that is what we're getting it. So here we won't get 60, here we get 30 only. Here we get 30 only. So 6 and 6 get cancelled. How many times? 6 cube times. So total how much we're getting, guys? 91 by 6 cube. 6 cube is 216. That's what we're getting it. Clear now? So guys, is it clear? Everyone understood this? In 5 into 6 itself, we got 2, 3, 3, 2. Both we got it. Correct. Exactly, correct. Raja, correct. Second case, we should not multiply with 2. Correct. Correct, guys. Correct. Guys, is it clear? Everyone understood this? Right, perfect. Chalo, let's move to the next one. Yeah, this is the next question. Omega is a complex cube root of unity. A fair die is thrown 3 times. The R1, R2, R3, the numbers obtained on the die is, then the probability that omega power R1 plus omega power R2 plus omega power R3 is equals to 0. So then what is the probability that probability of A is equals to n of A by n of S. First we'll calculate n of S. So n of S is how much? 216, right? When 3 dice are rolled, what is the n of S, guys? 216. And n of A we should calculate. So for that what we can do is, we'll take different cases. Omega power R1 plus omega power R2 plus omega power R3 should be equals to 0. So what is the possibilities? We'll just calculate. First case. R1 comma R2 comma R3 is equals to 1, 2, 3. This is one possibility. Clear? Next, 2, 3, 4. This is one possibility. Next, third case. 3, 4, 5. This is another possibility. Next, fourth case. 4, 5, 6. This is another possibility. Guys, clear? Correct, exactly. Consecutive numbers, this is one possibility. Next possible cases are, so whether you take 1, 4 or 1, you're getting same numbers only. So guys, whether you take 4 or 1, same cases only we get it. So otherwise what you can do is, this how many ways we can arrange it? 3 factorial ways, this 3 factorial ways, this 3 factorial ways, this 3 factorial ways. This we can do it, correct now? Each is 3 factorial ways. Why? Because 1, 2, 3 we can take it, 2, 3, 1 we can take it, 3, 2, 1, 1, 2, 1, 3, 2, all this we can take it, correct? Right. Next case is, instead of taking 1, I can take 4. So 4, 2, 3 I can take it. 4, 2, 3 already over. Okay, don't take 4, 2, 3 then. 4, 2, 3 is already over, guys. So tell me next case. What is the next case, guys? 156, can I take it? Can I take it 156? 156 how many ways? 3 factorial ways. Next, sixth case. Sixth case is what, guys? 153, can I take it? This is 3 factorial ways. Next, seventh case. Seventh case is what? 126, can I take it? Yes, this is 3 factorial ways. Correct or not? Next, eighth one. What is it, guys? 426. 426, correct. That is also fine. This is 3 factorial ways. Next, 126 is over. 426 is over. 423 is already over. 153 is also over. So tell me, guys, any other cases? That's it, right? Only 8 cases we're getting, right? So let's write it here. So if you write it here, 8 into 3 factorial is how much, guys? Isn't it 8 by 36? Isn't it 2 by 9, guys? Correct now? So 2 by 9 is the correct answer. So guys, is it clear how I am calculating it? Why? Because the basic concept we are using here is omega plus omega square plus omega cube is equals to 0. Because 1 plus omega square is 0, guys. If you take omega common, the same expression only be getting it. And omega power 4 is same. And omega square and omega power 5 is same. And omega cube and omega power 6 is same. Correct. So guys, is it clear? Omega cube and omega power 6 is same. Omega square and omega power 5 is same. Omega and omega power 4 is same. That's why we can take all these cases. 8 cases we are getting it total. Total 8 cases we are getting it. All these 8 cases, each again 3 factorial cases. That is 8 into 3 factorial. Which is total 2 by 9. So 2 by 9 should be the answer. Chalo, let's move to the next one. So guys, better what you can do is, you can analyze this way. Instead of using any other method, instead of taking 3n plus 1 or 3n plus 2 method, instead of doing that way, better if you can analyze this way. Only why? Because why to analyze this way is, hardly we'll get countable cases only. 8 cases means what? Easily we can count it. Correct or not? If there is 100 cases or 200 cases, we can't find it manually. We can't count it manually. But here number of cases are finite only. When there are very finite number of cases, 8 cases means easily we can analyze it, guys. Same way we can see here also we are analyzing it. Each and every case we are analyzing it, if you observe. When there is finite number of cases, see here also total 5 cases we got it. When there is single digit number of cases are there, better if we can count it manually instead of using any generalized method. So guys, clear? Right, exactly, correct. So what we can do is, 3 places are there. Here we can take 1 or 4. Here we can take 2 or 5. Here we can take 3 or 6. So here 2 into 2 into 2. Total 8 cases are there. This is one method. Okay, like this. 1 4, 2 5, 3 6. So total 8 cases we are getting it. This is also fine. Guys, is it clear? 9th case. What is the 9th case? Tell me. Stylish boy, what is the 9th case? Only 8 cases we are getting it, right? Guys, is it clear? So 1 or 4 we can take it. 2 or 5 we can take it. 3 or 6 we can take it. Why? Because omega power 1 is equals to omega power 4. Omega square is omega power 5. Omega cube is omega power 6. That's how either we can take 1 or 5, same result. 2 or 5, same result. 3 or 6, same result. And then 2 into 2 into 2, 8 cases we're getting it. Clear now? There is no 9th case, right? Correct, exactly. Perfect. Yeah, this is the next question. 3 distinct numbers are chosen at random from the first 100 natural numbers. Then the probability that 3 of them are divisible by both 2 and 3. Probability that 3 of them are divisible by both 2 and 3. So guys, let's do this question. So probability of A is equals to n of A by n of S. So tell me, what is n of S, guys? We need to select 3 distinct numbers. How many ways we can select 3 distinct number? Only selection, guys. So isn't it 100C3? Okay, right. So guys, now tell me, those are divisible by both 2 and 3. A number has to be divisible by both 2 and 3 means what? It should be divisible by 6 only, right? Can I say that the number should be divisible by 6 only, right? 6, 12, 18, correct or not? 24, so on up to what? 96, right? 96. Total how many numbers are there, guys? In this, total how many numbers are there? 15 or 16? 16, right? 16 numbers are there, guys. 16 numbers are there. So what he is saying, each and every, all these 3 digits, all these 3 distinct numbers should be divisible by both 2 and 3. That means it should be divisible by both 2 and 3 means it should be divisible by 6. It has to be divisible by 6 means we need to select these 3 numbers out of the 16 numbers only, right? So it should be 16C3 or not? Is it 16.3 or not? Yes, exactly. So now let's simplify this. How much we get it? 16C3 is 16 into 15 into 14 by 3 factorial by 100 into 99 into 98 by 3 factorial. So tell me how much we get it. 3 factorial cancelled. How much, guys? Anything getting cancelled? 1500. So here 3 times and here 20 times. 20 times. And 3 and 99. How many times? 33 times. Next. Denominator 33. You can check it actually. But okay, why to take risk? Let's calculate. So this we're getting like this. 16 into 14 by 20 into 33 into 98. So let's simplify it again. So tell me, guys, this is 4. This goes 4 times and this goes 5 times. Next. So tell me, guys, 98 how many times? 49 times. And here 2 times. And here 2 times. And here 7 times. So tell me how much we get it? 2 into 2, 4. Right. 4 by 35 into 33. That's what we're getting it. So isn't it option D, guys? Isn't it option D? Which is equals to 4 by 1155 only. Isn't it 4th option? Everyone understood this or not? Correct now? Right. Perfect, guys. That's it. So that's it for today, guys. Okay. So see you everyone on Monday. So next class is going to be on Monday, Wednesday, Friday, 9:30 p.m. Every 9:30 p.m. every alternate days. Monday, Wednesday, Friday, 9:30 p.m. We'll have this YouTube session. So guys, will we do more questions on probability? In next class also we'll do more questions on probability. Right, definitely guys. Definitely. Chalo. So guys, let's end the session, everyone. Take care. And you can find the notes, PDF notes of this. PDF of notes, you will get it after some time. You can find it. Okay. Right. Chalo guys. Bye bye. Take care. Good night guys. Good night.